again, we're at a cross section. You could make some broad generalizations. Important thing to realize though in the lower limb, and I mentioned this in class, and I'll try and mention it again when I see you in class again. Well, in the upper limb, this is upper limb. Let's say that's the shoulder joint. There's our elbow joint. There's our arm and our forearm. Generally, if a muscle, flexes, if it crosses both joints, it's going to flex at the shoulder and it'll flex at the elbow. It's all flexion. All the anterior compartment stuff in the upper limb, flexion, flexion, flexion. Posterior extensors, right? Something weird happened in the lower limb. So if this is my hip joint, this is my knee joint, and then actually there's my ankle, you can see everything got zigzagged. And that didn't happen in the upper limb. Actually, we could do a wrist joint. There's your hand. But this got flipped around. So in general, if a compartment, say in the anterior compartment, or actually let's do the posterior, and say the posterior compartment here, right here, actually they cross both joints. In the posterior compartment, instead of having consistency of saying extension, extension, extension at one joint, extension at the other joint, instead the posterior compartment there of your thigh, which by the way is these guys, they will extend at the hip joint, but they flex at the knee joint. So opposites. And these are also collectively called the posterior compartment, the hamstrings. So long, skinny muscles that literally, they mean hamstring because you string up a ham with those muscles. So if you kill a pig and you cut its throat and you got to drain the blood and hang it for a while in a meat locker, these long, skinny tendons are great for hanging up that pig. So that's where the name comes from, the hamstrings. And again, they attach and they cross the hip joint so they can act on it. They will extend your thigh at the hip joint, but they will flex the knee at the knee joint. Flex the leg at the knee joint right there. So opposite the leg. Yeah, everters are lateral. Hopefully that makes sense. You're pulling your ankle joint in that direction. So dorsiflexors in the anterior, and then the massive posterior compartment, plantar flexion. So when you think about it, plantar flexion, it totally makes sense why that would be the biggest compartment. Because think about what you do when you plantar flex. So you stand on your toes, you realize you're lifting almost your entire body weight. Okay, so the posterior compartment, superficial. One other point. So I'm backing up. I did some deep stuff in the leg. Now the superficial posterior compartment, these strong muscles, which in your lab and I think your textbook doesn't use this term either. I learned them as triceps surae. You don't have to remember that. I won't ask you on the exam, but it might be helpful to think of them as a triceps because, well, they have one common attachment. Triceps and biceps are defined as having, various parts with separate attachments, and then one common attachment, that would be a biceps. And then triceps is going to have 3 separate ones on one side and then a common one on the other side. Well, that's true for really gastrocs and soleus, because gastrocs, 1, 2 muscle bellies, and then deep to those 2 is the one soleus, which, by the way, soleus means fish, like fish fillet, and anatomists thought soleus looked like a fish fillet, which it kind of does. Anyway, 1, 2, 3 common attachment on the calcaneus. So that's just helpful for me to remember because the attachment's so easy. So I think of them together kind of like a triceps because they are. And then you see this person standing on their toes. You can really see the gastrocs sticking out because they're the most superficial. Actually, soleus is the meatiest one, deep to it. But remember, plantar flexion is it's lifting your entire body weight. Just a few inches, but still your entire body weight. So these 3 together are really, really strong, and they just yank on the calcaneus and pull it superiorly, which would really be plantar flexion technically. But you can imagine that they're all attaching here. They shorten, you stand on your toes. I know the biggest nightmare is all the long, skinny ones. Not as bad as the forearm. Just want to point out one important thing. There. Hallucis, the big toe. Something interesting about both the anterior and the posterior compartment. Hallucis, the quote muscle belly, yeah, that's the red part where the actual muscle tissue is. In both cases, it's lateral, and yet your big toe is medial, isn't it? So notice that, it crosses over. You're not going to always see this because they don't always have the cadaver, like the dorsal of the dorsum of the foot there dissected out. So you're not going to see the tendon moving over. You might just see the muscle belly, the muscle tissue. It's always going to be lateral in the case of anterior, and over to the deep posterior. Here we go. Deep posterior. Hallucis is lateral, and it is going to cross over on the plantar surface of the foot, that tendon, over to the medial side. This again is an artifact of flipping our legs and our feet over way back in evolutionary history. But I guess the important thing that I always like to point out to students is, like, when you find your medial lateral, there's your toe, there's your little toe, there's your big toe. So, medial and lateral. Hallucis is going to always be the muscle belly that's way lateral. Okay, I wanted to point out here this quadriceps group that for the most part, they are powerful extenders at the knee. So if you were like a soccer player, then these would be very important. So there are 4 of them. These 3, the vastuses, not only do they share a name, they also, very importantly, all come from the femur, which, there they are. There's the 3 for the femur, and go down and attach to the tibial tuberosity, which, by the way, that is the one attachment I would remember for all these. Tibial tuberosity, they all share it. So that's the 3 vastuses. But notice, this is important, they do not cross the hip joint. They do not go as far as the ilium here, but rectus femoris does. Rectus femoris is the exception. It comes from, I'm sorry, tensor is here. It's the best image I could find on the web. But rectus femoris also attaches there on the ilium. And it attaches all the way down to the tibial tuberosity. It crosses both the hip joint and the knee joint. So it can act on both of them. It will flex at the hip joint, and then remember opposites, extend at the knee joint. Along with the rest of these guys. They're all extensors at the knee joint. And I mentioned way back when we were doing bones, I would talk more about the patella. The patella is fascinating. Most people think it's there for protection when I ask the function. It is not. It is there for leverage. So lever is something where you use less force to move the same amount of weight. You probably have all done something like this. If you need to lift a heavy box and maybe you could jam a crowbar underneath there and lever it up, so you got a big heavy box and you stick like a crowbar under there like this, and then you push down on the crowbar, pushes up the other end, you can lift a heavy box. A little less easy to conceptualize than a crowbar, but trust me, there's the femur, there's the tibia, and the patella is actually sitting on the femur right there. And then we have the quadriceps muscles. So coming down here and attaching onto the tibial tuberosity. And so notice that there's a distance, that patella creates a distance. That is your lever, that distance. And no, I won't ask you about that. I just want you to know the function of the patella is to increase the amount of, force, the amount of pulling power, really, of the quads. So without your patella, your quads could not extend your knee as forcefully. Same amount of muscle mass, same amount of strength. You could not kick a ball near as hard. So if you lost this patella for some reason and you were a soccer player, your career's over.